Welcome, curious minds. Ever pondered on the concept of time? Is it just about clocks and calendars, or is there more to it? Let's embark on a journey through the labyrinth of time. It's more than just ticking clocks and flipping calendar pages. It's a concept that's as old as civilization itself, and yet it never ceases to mystify us. Time, it influences every aspect of our lives. From deciding when to wake up to scheduling our work and leisure, time is the invisible puppeteer that controls the strings of our daily routines. But it's not just about scheduling. Time also plays a crucial role in how we perceive and interact with the world around us, how we make sense of our past, how we live in the present, and how we envision our future. And then there's the biological clock, ticking inside us, driving the rhythms of life, from the beating of our hearts to the aging of our bodies. Time, it seems, has its fingers on the pulse of life itself. But time is not just a human construct or a biological rhythm. It's a fundamental concept that transcends disciplines and permeates various fields of study. In physics, time is a dimension, as real as the three dimensions of space. In philosophy, time prompts existential questions about destiny, free will, and the nature of reality itself. And in biology, time governs the rhythms and cycles of life, from the circadian rhythms that regulate our sleep to the seasonal cycles that drive the migration of birds and the blooming of flowers. Yet despite its omnipresence and significance, time remains one of the most elusive and enigmatic concepts. It's like trying to grasp water. The more tightly you try to hold it, the more it slips through your fingers. Time, it seems, is deeply woven into the fabric of our existence, and yet it remains one of the most elusive concepts. So let's delve deeper into this enigma. Let's try to unravel the mysteries of time. Because understanding time is not just about reading clocks or planning schedules, it's about understanding the very nature of our existence and the universe we live in. So what exactly is time? Is it constant or does it vary? Let's delve into it, shall we? Time, in its simplest definition, is a measure of the sequence of events and the duration between them. It's a tool we use to mark when something happens and how long it lasts. Think about the ticking of a clock. Each tick represents a second, a minute, an hour, and so on. This ticking, this progression, is our way of measuring time. But it's not just about the ticking of clocks. Time is also about perception. We perceive time as a linear progression, past, present, and future. The past is where events have already happened. The present is where events are happening right now. The future is where events are yet to happen. This perception of time as linear is deeply ingrained in our minds. It's how we make sense of our experiences and our existence. We remember the past, we live in the present, and we anticipate the future. It's a continuous, forward-moving stream that shapes our reality. But here's the thing. Our perception of time is subjective. It's not absolute. It can vary from person to person, and even from moment to moment. For instance, when you're engrossed in a good book or a fascinating conversation, time seems to fly. But when you're waiting for a bus or sitting through a dull lecture, time seems to drag. This variability in our perception of time is a reminder that time is not just a physical quantity. It's also a psychological construct, a product of our minds. So, is time constant? Well, in a sense, yes. The ticking of clocks is constant. The progression from past to present to future is constant. But our perception of time is not constant. It can change based on our experiences, our states of mind, and even our cultural backgrounds. In essence, time is our way of making sense of the universe's constant change. It's a framework that helps us understand the flow of events, the rhythm of existence, and the dance of life itself. Time, in all its complexity and simplicity, is a testament to the ever-changing, ever-evolving nature of the universe. Now, if we dive into the realm of physics, things get a bit more complex. When we talk about time, we often think of it as a steady, unchanging constant. But in the intricate world of physics, time is seen as a dimension. Yes, you heard that right. A dimension, much like the length, width, and height that define the physical space around us. This concept of time as a dimension is a cornerstone of Albert Einstein's theory of relativity. It's a mind-bending idea, but it's also a fundamental truth of our universe. Picture the universe as a four-dimensional fabric called space-time. This space-time isn't a static thing. It's dynamic, bending and warping in response to the mass and energy within it. Think of it like a trampoline. If you place a heavy ball in the center, the trampoline dips, creating a curve. This is essentially what massive objects like stars and planets do to space-time. They curve it. But here's where it gets truly fascinating. This curvature of space-time affects not just the path of objects moving through it, but also the flow of time itself. According to Einstein's theory of general relativity, time passes more slowly the closer you are to a massive object. This is known as gravitational time dilation. Now, this isn't something we notice in our day-to-day lives. The effect is far too small on Earth. But in extreme environments, like near a black hole, time can slow down significantly compared to farther away. This means that if you were to watch a clock falling into a black hole, you'd see its ticks getting slower and slower. So, is time constant everywhere? In the vast world of physics, the answer is a resounding no. Time is not some unchanging entity. It is a dynamic, flexible dimension that bends and warps in response to the forces of the universe. Ever heard of time dilation? It's not science fiction, it's reality. Now, let's delve into one of the most mind-bending realities of time: time dilation. Picture this. Two best friends, one stays on Earth while the other embarks on a high-speed journey into space. According to Einstein's theory of relativity, the friend on Earth will age faster than the one in space. Surprising, isn't it? This phenomenon is known as time dilation, an actual difference of elapsed time between two events as measured by observers moving relative to each other. In simpler terms, time can slow down or speed up, depending on how fast you're moving relative to something else. Let's make this a bit more tangible. Imagine you're on a spaceship, zooming away at near light speed. Your onboard clock seems to tick as it always does, but when you look out at the universe, it's a different story. The universe's clock seems to be ticking slower. This is time dilation in action. Now, why does this happen? It's all thanks to Einstein's theory of relativity. According to this theory, space and time are intrinsically linked, forming a four-dimensional fabric called space-time. Massive objects distort this space-time, and as a result, time ticks slower near them. The same theory also suggests that time can slow down at high speeds. So if you're traveling at the speed of light, time would stand still for you while it would continue normally for someone stationary. This is why our space traveler friend would come back younger than the one who stayed put on Earth. All this might sound like a plot straight out of a science fiction novel, but it's a scientifically proven reality. Time dilation has been tested and confirmed in numerous experiments, including the famous Hafele-Keating experiment, which involved atomic clocks on airplanes. So there you have it, time dilation, a phenomenon that quite literally stretches and squashes time. Yes, time can stretch and squash. It's all relative. Scene script. Let's turn inward now. How do we perceive time? Our perception of time is a subjective experience, shaped by a confluence of factors. It's a fascinating realm where psychology intersects with physics. Consider when you're engrossed in an activity you love. You're so absorbed in the task that you lose track of time, and hours may pass like minutes. This phenomenon, known as time's subjective acceleration, is testament to our mind's ability to warp time perception. On the other hand, when you're stuck in a boring meeting or waiting for a delayed train, each minute feels like an eternity. This is time's subjective deceleration, where periods of inactivity or disinterest can stretch our perception of time. Our emotional state also plays a significant role in how we perceive time. When we're happy or excited, time seems to fly. But when we're anxious or sad, time appears to drag on. It's as if our brain has its own internal speedometer, adjusting our perception of time based on our emotional state. Moreover, age is another crucial factor in how we perceive time. For a child, a year can feel like a lifetime, whereas an adult might remark how quickly the years are passing. This difference stems from the proportionality theory, which suggests that as we age, each subsequent year represents a smaller proportion of our lives, making it seem shorter. Let's not forget attention, a key player in this game. When we pay close attention to something, time seems to slow down. This is because our brain processes more information, tricking us into thinking more time has passed. In essence, our perception of time is not a constant stream, but a fluid experience, influenced by our minds and emotions. We are all time travelers in our own right, journeying through the maze of time at our own unique pace. So, the next time you feel time slipping away or dragging on, remember it's not just the ticking of the clock, it's your mind, your emotions, and your experiences shaping your perception of time. Our internal clocks, it seems, have their own unique tick-tock. Time, as we've seen, is a fascinatingly complex concept. This journey we've embarked on together has taken us through the intricate labyrinth that is the concept of time. We've discovered that it's so much more than the relentless ticking of clocks, the change of seasons, or the aging of our faces in the mirror. Time, in its essence, is a measure of events, a cosmic metronome that beats to the rhythm of the universe. Peeling back the layers, we've explored the simplicity of time, and yet also its complexity. Time is not just a linear progression from past to present to future. It's a multi-dimensional fabric woven into the very fabric of reality itself. It's the shadow that follows every particle, every wave, every burst of energy in the cosmos. We've ventured into the strange realm of relativity, where time is not constant. It bends and warps, slows and quickens, under the immense influence of gravity and speed. A minute on a speeding train is not the same as a minute atop a mountain or a minute in the depths of space. Time, as it turns out, is a relative concept. We've also touched upon the subjective nature of time, how it can stretch and contract in our minds. An hour spent in joyful company can seem to pass in the blink of an eye, while a minute on a hot stove can feel like an eternity. In essence, time is a measure of change. It's the yardstick we use to chart the course of our universe, from the birth of stars to the decay of atoms. It's the lens through which we perceive our world, from the fleeting moments of joy to the enduring scars of sorrow. And it's the scale on which we map our lives, from the innocence of childhood to the wisdom of old age. With time, we measure our universe, our world, and our lives. It's a concept that's as profound as it is practical. Now that you've journeyed through time with us, what are your thoughts? Ponder, reflect, and allow the mind-bending reality of time to sink in. Let it seep into your everyday life. Does it make you appreciate each tick of the clock a little more? Or perhaps it has left you with more questions than answers. That's the beauty of time. It's a complex concept that continues to baffle the brightest minds. We encourage you to engage with this channel, to be an active part of this journey. Share your thoughts, your questions, your curiosities. Do you have an interesting fact about time? Perhaps a personal experience that resonated with our discussion today? We'd love to hear it all. So, plunge into the comment section below and let's continue this dialogue. Remember, each moment you spend exploring the mysteries of time is time well spent. Until next time, stay curious.